So guys, we are going to look at the find methods with the stream. So we want to explore the first one, method of the stream. So if you can look at what we are doing here, we are getting all the methods of a stream class. This is a reflection, guys. So it will return all the public methods defined inside the stream class, together with super classes or interfaces that it actually implements. So if I can just do a quick for each so you guys can see method inside methods, and I can just say sys out method dot get name, and then for now I'm just gonna remove this code. So you see it returns all those methods to us. This is what I actually was implying. So now let's go back, now that you saw that we get all the method via reflection. So what we are doing here, we are saying convert that to a stream, then map that method. Remember, it's a method object, we are mapping it to get name. That means we are converting this to a string, so we just get the names of those methods. Then we can achieve the same thing that we did with printing. So basically here we can say dot for each, then we can see out, and then we can end our stream. I will just go back. So if we do this and remove this, we'll get the same results that we got before, as you can see. So for now, let me go back to this that we had. So now, after we have mapped from object method to string, we are doing the filtering. We want all the methods that end with match. We want to find them, and we want to sort them, and then we want to find any of them. So findAny will return any of them. It's not guaranteed to give us. Let's just read what the documentation says. It returns optional describing some element of the stream, or an empty optional if the stream is empty. It says this is a short circuit in terminal operation. The behavior of this operation is explicitly non-deterministic. So we see that it's non-deterministic, and it's short circuit, which means after we find something we stop doing. And findAny also, guys, it's a terminal operation. That means it consumes a stream. So let's see what we get after we run this code. We get all match. So let's say we want to remove this sorted. That means we are not sorting. Let's see what will come back to us. We have any match. Let's run it again. Any match. Let's run it again. Any match. Let's return the sort. We have all match. So let's say that we were not doing, and let's just say we wanted to print this. Sorry, for each, and then I'm gonna remove this for now, and then I'm gonna remove this. So that means we are printing all the methods. Okay, let me say, okay, I want to sort them first. So after that we say dot sorted. So let me just order this code nicely. Alright, so we want to print all those methods. As you can see, all match, any match, non-match. We sorted them and we want to print them all. So let me go back again to what we are doing. findAny. So findAny will just return an optional, as we saw. So what we'll then do, we say print this, or else if you did not find anything, just print no suitable match found. So if I was to put something that does not exist here, we are going to get no suitable match found as an output, as you can see here. This is what I like about the optional. This is very powerful also. You really need to use it. You see it was added in Java 8. Alright, we have seen the first use case. Let's find, now we want to use findFirst. So the first one was findAny, now we have findFirst. So what we want to do here, we're still using, since this is, we are dealing with double stream, findFirst will obviously, since it's executing on double stream, it will return optional double, as we can see. And yeah, that's it. So now when you have optional double, you can get values from it pretty much the same way you work on the optional. This one is a specialization of it. So if we come here, they will tell you that it models the very same optional that we are having in this other class. So what we have here, we have all these numbers. Then what we want to do is we want to filter them. This is the filter. Any number that is greater than 0. So what we can see is number x, and yes, any temperature that is greater than 0. We want to sort them, and we want to find first, and we want to print the first one we found. So let's run this code. You see that we found 2.2. So let's say we didn't sort, we just leave it like that. You see that it affects our output. Okay, let's say we want a number that is greater than 10. Let's see what's going to happen. You see that you get an exception because you didn't handle it well here. The way you are doing here, you assume that the number is always there. So what you normally need to do, you need to say temperature dot is present. Then if it's present, you print it. If not, you don't do anything. So if I run this code, I'm not going to get an exception. If I put 0 back, I will get something printed, because now I only execute this method if there is a number existing in the optional. Then you also have if present. So basically you can substitute this guy here, like this code here, you can substitute it with temperature dot if present. Then what you can do, you can take this code and so basically you want to delete this. What is missing here? Alright, so what we want to do here, since it's a consumer, we know that consumer receives something, and then here we want to say okay, we want to do something like this, and we run our code. So you can see it's able to find it for us. So if we put 10 here, we see that we don't get into an exception because of this if present. So let's print this x. I want us to print this x, so I'm gonna say printf, and I'm gonna say put some so what I want to do is I want to do this so that you can see what the value of x is, and I will put x here, then I will run this code. Okay, we have to remove that because the condition is not hold. So we see that it's the very same value we are talking about. So basically we don't even need this value here. We can just put our x, because it's the value that will be passed when there is an object present, like the optional has a value. It will pass that value and then we can be able to print it. Then we have a find max. So here I have a couple of methods. Two of them that we have overloaded max, and the first one takes a primitive string which is in stream. The second one takes just a normal string. So what we are doing here is that we get the max from a stream. So since it's an int stream, it will go into optional int, as we saw with optional double. So we know that max is a terminal operation, which means it consumes the string. You get the maximum from the string, and this maximum will be gotten based on some comparator or some default comparison that is done for you. So, and then what you do here, you say if max.if present, you are printing this, or you can do it, you can also achieve the same thing with this statement. So this is one thing, is just that this one is more elegant. So if I was to comment this code and to run this one, we will see that we get 99 as the maximum value here. So the first one was printed here, the second one was printed here. So let me comment this one and uncomment this one. So we're still achieving the same thing, but now we are using a string. So we see that we're saying term.max. So if we remove this, we see that we are having a problem. We have to pass this a comparator, because it's a type. When you just give max like this, it doesn't know how to compare those objects to find out which one is the largest. So you need to pass it a comparator, int comparator. When you say stream int blah blah, although we know that int already has a comparator defined for it, it does not know about that information. You need to pass the comparator. But when it's an int stream, its max already uses a comparable that comes with an integer. That is why it's able to work for you. So for stream int max, you must give us a comparator, which is what we have here. So if we come here, we'll see that it needs a comparator. So now we are doing the same thing. If it's present, you get that maximum.get, you print it. If present, you can just print it like this, like we did in the other time. So this is what you can achieve, guys, with this find. Here we just wanted to treat the max together with the find.